wanted to go over this one again. We did this in class a couple days ago. This is an example of where kind of a non-traditional question where it asks you to find the type 1 error without actually choosing an alpha level. In this case, rather than choosing an alpha and when to decide to reject a null, we've got a situation where it says reject a null if your proportion is more or less than a certain value from the mean, right? The next page, we'll see exactly how we can work this out. Here, we wanted to talk about, this is the situation they're at. They told you the mean was going to be at 9,250. And they said if you had an average that was 500 or more or less, if it were outside of that range, then 8,750 to 9,750, then we would end up rejecting the null. So the question would be, what's the probability you're going to reject the null? And so that's easy enough. We just need to know the probability, the percent of the area under the curve outside this range. So there's a lot of ways I could approach this. These areas at the ends are the exact same probability, so I could find one of them and then simply double it. I tend to take a different approach. I found inside here, I know that the area total adds up to 1, so if I find this percentage, I can just subtract it away from 1, and that will leave me behind the actual number. So the answer is obviously C, and this is how you do it. Now, this one's a little different. We do use, it's a quantitative problem, right? It's using the square root, it's using the standard deviation divided by the square root of n to equal your standard deviation for x bar. Now, we're not going to do that tomorrow's test, but the only thing that would be different is if this was categorical, these numbers at the bottom would just be proportions instead of dollar amounts. Otherwise, it's exactly the same kind of question. Okay, so we're going to work one where we're looking at a situation and we're asked to find the power of a test given a certain null alternative, and later on discovering that that alternative was in fact true, and we ended up failing to reject the null. So in this question, what is the power of the test if we use an alpha level of 5% and we have a true proportion of 35% rather than my original null hypothesis of 30%. So what we're going to do is we're going to set it up like this. We're going to draw in my original curve, right? And so this at the bottom, keep in mind, this is just a number line that we're putting percentages on. This is centered at 30%. We've decided that we're going to use an alpha level of 5%, right? So here is your alpha level of alpha equals 0.05. And we're basically going to set this up in a way so that we can figure out the power. So the first thing I want to do is, well, let me draw in the rest of the curve, kind of put it in context. We know up here some point, well, I don't want to put it in the wrong spot. So what we're going to do is we're going to go ahead and find what that number is. What's the value we would use to end up rejecting the null, right? So the question is, what is this number right here? That's the kind of first thing I want to know. So I'm not sure if that's going to be 0.35 or is it going to be bigger or smaller, so I don't want to put the other curve in yet. So we can find this number by saying inverse norm of 0.95, because 95% is to the left of the curve here. So this is 0.95. If you have in your calculator, you can choose to use 5% to the right. But majority of people, I think, have an older one, so this is how you would do it. And we're going to say that we're going to do 0.3 is the mean, and the square root of 0.3 times 0.7 divided by, let me tell you that, sample size. What is the sample size here? Sample size n equals 200. All right, so we'll do that, 200 here. And we can type this in, and at this point, we will be able to determine exactly what value would cause us to end up rejecting the null, or in this case, really, what value and greater would allow us to reject the null in this case. So I'm going to type this in. Remember that when you're typing in the standard deviation, if you haven't already done it, you can always just type that right into the field inside the inverse norm. It doesn't really matter. that kind of calculation is going to be okay. Always remember to add in your end parentheses for that. Otherwise, it's going to be kind of, it might give you an error if you try to do left or right. Now, so what we find out is this number is equal to 0.35, let's say 33. Okay, so so the actual null is just inside, or the true null is just inside that range. So I guess we'll put it right here, 0.35 is right there. So we have another curve that's really, this is where the center of the curve, of the true curve, lies. All right, and so what we would like to do is we'd like to extend the rejection. Remember, this line we're putting here, let me change colors. The line that we decided to originally reject or fail to reject is going to stay consistent. So reject here, and on this side we would fail to reject. Now, we're not really considering the fail to reject part. Right, we're talking about power, so we're interested in rejecting the null, right, in this case. Because I know I should have been rejecting null, because the probability that the percentage really isn't 30%, it actually is greater than 30%, it's 35%. So what we want to do is we want to find the area above this section, right in here. So once we found this number, it's just a matter of using normal CDF again, right? So we're going to be doing normal CDF of, that's going to be 0.3533, going up to 1E99, and then, okay, and then we're going to go all, let's see, the mean of 0.35, and standard deviation of 0.35 times 0.65 over 200. Now, notice that the curves aren't that really distinctly different, right? So they're relatively close. So I'm not expecting to get a very large power here. In fact, it should be less than 50%, because it's not half of the area of the curve yet. So here we're going to do 0.3533 is my lower, my upper 1E. I can type in my calculator, 1E99. The mean of 0.35, and a standard deviation of square root of 0.35 times 0.65 divided by 200. This gives me a percentage of 0.4610. So the power of my test in this example is only about 46% of the time will I reject the null correctly. 35% is definitely not that far away from 30% in terms of how many standard deviations we have. So in order to get more power, I could choose a smaller alpha level here and push that bar a little further away to 1% instead of 5. Or if I wanted to increase my sample size, I could shrink the width of these curves and make them separate themselves. And I would just basically, instead of having a wider curve like this, we'd have a narrower curve over each of these peaks and separate these curves so the areas would get a little bit bigger. But bottom line, here's an example of how you would do power. Let me just kind of recover that real quick, because it's not that complicated. First thing we do is we draw a curve using their original information. We have a 30% null hypothesis. We have a 5% alpha level right over here. And we'd like to know what number would I end up rejecting the null if I were to get a number bigger than, or in this case it's bigger than because it's greater than alternative. So if I get 35.33% or higher, we would end up rejecting the null hypothesis, right? So I want to reject, and I want to know what is the true percent of the time I'm going to do that. So that's where the new mean comes in, or the new proportion. The real curve, the true curve, the curve that I'm not assuming to be true, is the blue one. This is the true percentage, right? That's where the curve really exists. So I'd like to know if I'm going to be rejecting the null when it gets bigger than this, and I'd like to know under the new curve what area is greater than that number right there. And that's what you see me do right here. right? So we do normal CDF of 0.3533, 1E99, 0.35, and that standard deviation. And so we get a power of 0.4610. And of course, if you wanted to find type 2 error, you could just do 1 minus that value. So type 2 error would be 1 minus 0.4610 to get 0.5389 to be exact, if you don't round any. Okay, and so in this case, I didn't need type 2. It didn't ask me for type 2, but it did ask for power. Okay, hope that helps. If you want to try this example again, what you can do, you can mess around with the 5%, or you can change the sample size, maybe change the sample size to 200 or 300, or maybe even 500, and just see what happens to the numbers.